So in this video, I'll give you some idea on how to sketch the polar curves. And obviously these days with the modern technology and there are actually so many mathematical softwares available and some mathematical computer programming languages available to help you sketch the polar curve in a very nice way. But in this video, we'll just try to give you some understanding of the inner mechanism of how to sketch a polar curve. We understand that you can easily sketch a nice curve by using some computer softwares, but let's drop it for now. The understanding of how the curve is drawn is still quite important for you to understand the polar curves. And I'll just give you an example in this video. So for example, now you are looking at the curve which is presented by r equals sine of 3 theta. Please note that it is not convenient at all. If you try to transform such curve back to something you're already familiar with, for example, like the xy coordinates, so we don't want to do that kind of transformation. We want to stick with our plan. We want to just look at the polar representations of every point and you try to connect them. So basically we are using the first principle ever, which is about the plotting of the graph, to plot the points on the graph and we can connect them for any polar points. So let me write down some sketch here. So please look at my sketch here. Currently I'm giving you a polar grid and you're asked to plot the points on this graph and we need to know approximately how's the shape like. And let's do the plotting first. So let me do the computations of all these values based on the standard angles I give you here. So please look at the points we have found. Altogether you see there are 9 points and we have to try to plot it on the graph. For example, the first point is actually the origin, right? We start our sketch by using the origin. And the next point, what is the location? It is along the line theta equals pi over 6 because the angle is pi over 6 and the radius is 1. So the radius is 1 means the point is exactly on the unit circle here. And this point, of course, has the angle pi over 6, right? And just for the first 2 points, please imagine how you can connect 2 points. If you're trying to do something like this, I think it is totally wrong. For example, try to give me the connection like this randomly. It is totally wrong. Why? Because this green line, if you look at the points along this line, the angle here is all between this point and this point, right? Which means the angle is between pi over 6 and pi over 4, which does not make sense because if you come back to our table here, this table you see we're trying to gradually increase our angle from 0 to pi over 6 and we understand that the behavior of the sine function is that it gradually increases from 0 to 1 for the function sine of 3 theta. So the r gradually increase, which means the r is always positive from 0 to 1 and the angle must be between 0 and pi over 6, which means the line that you draw must be inside this angle from 0 to pi over 6, right? And so I think and the r, the radius gradually increase, maybe something like this you get, for example. And let's look at the next point. The next point, the third point is pi over 4 and the radius is 0.7. With pi over 4 for the angle is along this ray. 0.7 means the radius is a little bit less than 1. So I guess the point is approximately here. And same thing here, you see from the second point to the third point. The radius r gradually increase. I'm sorry, gradually decrease from 1 to 0.7 something, right? And and also because the radius is positive and the angle is moving from pi over 6 to pi over 4 gradually, so I can just connect the 2 points maybe by a line like this. And let's look at the next point. The next point, you see the radius becomes 0, which means you get back to the origin. So basically, we have to connect this third point to the origin again. And this part, once again, the radius is gradually decreasing from 0.7 something to 0. And the angle is gradually increasing from pi over 3 to pi over 4, which means the purple line must stay inside this range. And so I guess maybe we have a line like this. So if, for example, if you give me the alternative lines like this, if you use a red line to connect like this, I think it must be wrong because you see this part of the red line is out of the angle we look at, right? And it gives you a sense it must be wrong. So actually the correct line is something like this, you see. And the next point, we have to be careful. Please look at how the radius r is moving. Now it is in the negative territory, so it is decreasing from 0 to -1. That's the behavior of the function sine of 3 theta, when the angle gradually increase from pi over 3 to pi over 2. So originally, if the radius is positive, you see the way you move the angle is from pi over 3 to pi over 2. It should be sitting around this pi, the positive one. However, we understand that if you go back to the left-hand side here, the radius on this range is negative now. So it means that you have to do a reflection, right? Because in the last video, we have explained it already. Negative radius is allowed. It essentially means you have to do a reflection to the opposite end of the ray you look at, which means that actually the purple line is around this after the reflection because of the fact that the radius is negative. You have to move from 0 to -1 for the next point. And this point, the fifth point, basically means the angle is pi over 2 and -1 is here, right? And you have to connect the origin now to the next point inside this pi. So I think the connection may be something like this. I hope you agree with me. And let's look at the next point. The next point is the point number 6. The radius is again 0 and the angle is 2 pi over 3, right? You have to come back to the origin from the current point we are in. And because of the fact that the radius is still in the negative territory, you know, from -1 to 0, and you are moving around the angle from pi over 2 to 2 pi over 3. Once again, there's a reflection along the way again, so it means we have to gradually go along this angle after reflection from this point back to the origin. It has to be inside this pi, so it means we expect the line to be something like that. And we can actually finish this sketch. Well, for example, the next point is good that we come back to the positive range for r, and the angle is gradually increasing from 2 pi over 3 to 3 pi over 4. So it means that actually the radius is 0.7 positive, so it means I expect the next point to be somewhere here because we are increasing the angle in this way. So the purple line must be inside this pi from the origin to the current new point. So I can maybe sketch a line like this. And the next point is good because the radius is positive. It goes back to 1 along the ray 5 pi over 6, right? So we just have to connect these 2 points like this. There's nothing to do. And the next point, once again, we come back to the 0, which is the origin when the angle is pi, right? And so I think the only way we can connect is because of the fact that the radius is positive. We can connect the 2 points like this. So basically, the graph is done. You can keep going for more points. For example, you can go to the next point forever. You can keep going until you finish the whole sketch from angle 0 to 2 pi. But I think it is not necessary. You can try yourself. You're basically repeating the path you have. Once you reach the origin, when you're at the angle pi, you keep repeating it yourself like this, yeah. So basically it's the sketch we have, and of course our picture now is not perfect, and in a perfect picture like the one you saw usually online by using some mathematical software, all the 3 loops here are actually identical. So I should say that there are actually 3 loops now. And basically, this video, as I said at the beginning, is to give you some rough idea on how you trace along the curve. We understand already that these days, using computer, you can easily get some very nice figures. But the idea the how to sketch the curve is still quite important, mathematically speaking. And I hope this picture gives you a sense that why using the polar function and sketch a polar curve is important, because if you use the rectangular coordinate, it is so difficult to find a function y equals f of x such that you get such a nice symmetry where you actually get 3 identical loops. And that's basically the end of this video.